Alright, CNT140. We're looking at Chapter 7 on designing our premise cabling system. Here we'll look at some of the cabling, closet requirements, those sorts of things for our cabling system. The nice part about this chapter is it's going to review some things we've already done in the lab. It's going to review some things we've already done in our bid specification project, and actually serve as a reminder of lots of things that we've talked about and bring it back to the surface of why we're doing certain things. So let's dig in and start working our way through. First part of the chapter, they remind us that AT&T, when they were doing phone systems, had done a survey and determined that most of the connections in a building were about 100 meters, 300 feet away from the closet, the phone closet, if you will. And that determined kind of the structure they were going to use, and that eventually evolved into our cabling standards and premise cabling and structure cabling standards that we use today. So it kind of has our roots in that original AT&T cabling system for phone. So they're going to walk through a whole bunch of different areas of our cabling structure. So some of this, again, will be some review and refresher of things we've talked about. Some of the first areas they talk about is the service entrance, equipment room, main cross connect, and things like backbone cabling. So let's work through some of those. I'm pulling up things we've talked about before. Our main equipment room, that is the main room that pretty much the ISP connection would come into, and you would have your main rack of equipment, maybe your firewalls and routers and those sorts of things, and maybe any other phone equipment or things like that that you'd have for the building, maybe even some servers for the building. So you'd have closets that look like this. Here's our server room in a data center, if you will. Here is a closet that actually has some chassis switches, and this actually does have some phone equipment on the wall. But a lot of our main rooms start looking more like this, where we have rows of locked up cabinets with servers in, routers, switches, that sort of thing. The next area they talk about is our TR, telecommunication room, that acts as the interconnection between the backbone cabling, the horizontal cabling, and our building. This also has typically just switches and maybe patch panels, or actually patch panels and some switches, maybe some other equipment, but usually that type of equipment. So we're now talking about these closets, the closets that would be on each floor of our building, or maybe each wing of our building, servicing just that wing or that floor. So we would have things like this. We'd have rows of patch panels and rows of switches, and that might be it. That might be the only thing that's in there. Here's some patch panels and switches. There's a few other pieces of equipment down here, maybe some UPS and that sort of thing. That is the interconnection point between the backbone cabling, most likely the fiber optic cabling connecting from floor to floor, going from switch to switch. And also, and actually we're seeing here the fiber optic cabling between the closets, switch to switch. This is the type of cabling we'd be finding, fiber optic plugged into our switches, probably down through conduits in the floor, fire stopped as it goes to the other closet below. And then interconnecting with our horizontal cabling. The copper cabling from the workstations back into the closet into the patch panels. So horizontal cabling coming back into the closet. Horizontal cabling coming back into the closet. That is your TR. Your TR is the interface between those two. This backbone cabling and the horizontal cabling. That's the job of the TR. Reminder about horizontal cabling, we have typically solid core conductor or solid conductor cabling for this part of our structure, and that horizontal cabling is typically installed in trays, bundled, organized, gentle bend radius and so forth, but cabling is supported the whole way through the run. And that horizontal cabling goes out to the work area. The horizontal cabling gets terminated out in the work area into the outlet out there. Outlet on the wall, that sort of thing. The work area itself then would be this kind of area in an office or building where the user is, and that's where the outlet is for them to plug workstations into. The work area that has the outlet jacks on the wall that they're plugging into, and the patch cables that would connect from the outlet to the computer. The work area patch cables, remember, are stranded conductor for flexibility, but we need to keep their distance short because that has more resistance, so it's going to weaken the signal more. The facilities where these cables are run to connect the work area back to the closet are referred to as pathways and spaces. Our 569 standard is about pathways and spaces. So usually any kind of specs or requirements we would look up in this standard to know this is the distance, or this is the dimensions, or this is the separation from. These would be the kind of things. Those would be the kind of things you'd look up in this standard, the 569 standard. All of our equipment rooms require conditioned power, usually power that runs through like a UPS, because the power going in the UPS is charging the battery, and the battery is providing clean power to the equipment in the room. That would be basically conditioned power. A separate data ground for this closet, so we don't have ground problems from other equipment or other sources on the floor. Air conditioning, heavy ventilation here to keep the equipment cool, and adequate floor space that you can actually put a rack or a cabinet in there and actually get around it to open doors, work on equipment, close it back up, that sort of thing. Again, your 569 standard has specs on, the 569 standard has specs on what is required for the closet, and it's usually in the general architectural area of that. Again, you could look that up to know what is needed in the closet. Backbone cabling can either be copper or fiber. We can actually use a copper backbone connection between switches, or we can use a fiber optic connection. A lot of times we use fiber optic for bandwidth and distance, but sometimes even electrical isolation between the floors. An electrical short on one floor would not travel through your backbone cabling to another floor. The 568 standard specifies two multi-mode fibers, the 62.5 and 125 and the 5125. You could use the OM1, that was the original multi-mode fiber that was adequate for like gigabit speeds. As they moved beyond gigabit speeds, then they moved into 5125, higher bandwidth capability. And here reminds us the OM3 laser optimized could give you gig Ethernet, and OM4 laser optimized could give you 10 gig Ethernet connections. Single mode is also specified for longer backbone links, like in a campus environment or connecting buildings together, but we won't typically find it inside a building, connecting closet to closet inside a building. Horizontal connections have traditionally been unshielded twisted pair. That is the balance of really good performance, rather inexpensive, easy to terminate, etc. But with modern wireless having enough bandwidth for users, and many users working remotely and portably, in a portable manner, if you will, having robust or high bandwidth wireless in your facility is usually part of a design for those devices. So having access points with a high bandwidth connection, either through copper or fiber, would be able to support those needs in a facility. And again, that would need to be engineered into your design as well. Fiber optics is also a choice for horizontal, using the centralized fiber network that we've talked about a couple different times. We've talked about how this doesn't actually need this can go directly from the main closet out to the work area. Don't need a intermediate connection, don't need any terminations or patch panels in the middle of the run. So you don't need that telecom room. So this can save on not needing that telecom room on the floor. And save on the electric for the equipment in there, the heating and cooling of the equipment in there, I should say the cooling of the equipment in there. So it might actually offset installing fiber out to the desktop, if you will. Reminding us of this structure here out to the desktop, and there's usually a little unit on the desk, a fiber to copper switch, if you will, that your workstation would plug into. So the fiber could go the whole way out there. Your telecommunication room, again, is interconnection between backbone and horizontal cabling. Usually has the location of your switches. And a lot of times your backbone cabling from floor to floor, you literally have a fiber cable coming from this switch up to this switch and plugs in. So this is typically your telecom closets. Like I said, this chapter does a bunch of reviewing for us. So a little repetition is not bad. And here I remind you about, here's your backbone cabling between floors. Here's your horizontal cabling on the floor. The TR is that interconnection between the backbone and the horizontal cabling. Your TR is the interconnection from your backbone to your horizontal cabling. Cabling for premise networks has many options. Most are determined by the performance of the cabling. And as we've talked about before, our unshielded twisted pair cabling, over the years, the structure inside changed so that it could handle different bandwidths. So they put ratings on them to say, this category rating will support this bandwidth, this category rating will support this bandwidth. So category 5E, 6, odd magnet 6, all the way up to 8. Those, as we go up in numbers there, our bandwidth capabilities are increasing. They're able to support more bandwidth. Fiber rated OM1, OM2, OM3 that we looked at a little bit earlier. These, as they go up, are rated for higher bandwidth capabilities. Sometimes distance too, depending on your connection. Higher performance cable supports higher bitrate systems, but a higher cost. Usually the cabling costs a little bit more, the terminations might cost a little bit more. But a lot of times your install, you try to choose the highest level that's reasonable or affordable for the customer, so you have room to potentially upgrade later, and not have to redo the cabling, but I'll have the capability to increase your bandwidth. That's something that's usually a consideration. The main restriction for structured cabling is your distances of your cable runs. We know copper is limited to 100 meters. Your standards kind of arbitrarily set some distances on fiber based around that number. The book mentioned that. But fiber backbones usually have some more distance capability as we're connecting closets and so forth. Maybe a closet from building 1 to building 2. We have some greater capability for distance. I just kind of copied the chart over here from the book on, we know copper for data is limited to 100 meters. Multi-mode fiber for horizontal limited to 100 meters. It's capable of more, but limited to that. As we do multi-mode fiber for backbone, we know we're capable of a lot more distance there to connect closets together, potentially 2 buildings together. Think about Hacks Campus connecting Blocker and Hall Tech, or the Student Center over to Blocker, that kind of thing. And here's a reminder about the copper cabling, designed to run 100 meters in length, comprised of 90 meters of permanent link. That's the horizontal permanent link that we install and leave there, and then 10 meters of patch cables. So the 90 plus 10 gives you the 100 meters max for unshielded twisted pair. And the idea behind all this, if I keep it below length, my cabling should pass certification tests. Here's that structure again. Your horizontal cabling here limited to 90. Your patch cable here limited to essentially 5 and 5. Reminder, horizontal cabling is solid core, solid conductor fiber, or solid conductor cable. And then your patch cables are your stranded conductor cable for flexibility purposes. Fiber has a little bit more, more bandwidth, more lengths possible, as we talked about before. So with that, when they install fiber, you need to estimate the lengths and any kind of loss of that cable installed. That way you know if it'll meet the performance criteria for that link. That is actually calculations you can do. Any cabling we're installing needs to meet your flammability codes. We've talked about this before, so this should be a good reminder. When we deal with copper cabling, we have the communication multipurpose general, riser, or plenum. Look at that last letter. And remember, anything installed above the ceiling would need to be plenum. Between closets would need to be riser, and in the work area can be general. So if I look at the box or the cable, I can find out this is general, here is riser cable, and then here is plenum cable. Look at that last letter, and that'll be your clue for you. The same thing is going to apply for fiber optic. OFNG, OFNR, OFNP. And as I look at the cabling here, this actually just says plenum, OFNP, and then up here I see OFNR riser. So I would look at those ratings to know that I have the proper cable installed in the proper location. All right, we'll come back in the next podcast and continue on.